Hi, this is Mr. Erlin. Today I thought we'd talk about trigonometry. So prior to this point, we've had the ability to interact with angles in a triangle. We know that they add up to 180 degrees. And we've had the ability to interact with the sides of a triangle, in a right triangle at least, where we know that a squared plus b squared equals c squared. Well, trigonometry is the study of angles and side lengths in a triangle, combining them together. So the core that you need to memorize in order to be successful is this SOH CAH TOA. Seems silly, but it's actually really important. There are three trig functions we're going to work with this year. The first is called sine. It's abbreviated sin. It's actually sine. Second one is cosine. And the third one is tangent. But for our needs, we're going to look at this SO with the abbreviation of sine, sin. And what these three functions do is they reference an angle. So for example, if this is angle A, and I say sine of angle A, it tells you that the computation of angle A using the sine function will give me a fraction, a ratio, of the side opposite angle A and the hypotenuse. In other words, the sine of angle A will give you a fraction equivalent to the ratio of the opposite side divided by the hypotenuse. Whereas the cosine of an angle, abbreviated cos, gives you another ratio, but instead of it being the opposite over the hypotenuse, it's the adjacent side over the hypotenuse. And the tangent, abbreviated tan, of an angle gives you a ratio as well. This time it's the opposite over the adjacent. And that's what these all represent. Sine of an angle is the opposite over the hypotenuse. The cosine of an angle is the adjacent over the hypotenuse. And the tangent of an angle is equal to the opposite over the adjacent. So the first step would be to look at a triangle when we've got all side lengths given. Let's say we're doing angle A up here this time. And I want to find what the sine of angle A is, what the cosine of angle A is, and what the tangent of angle A is. Step one, I have to position my eyeball effectively. I have to say, this is my point of view. I'm looking from there. And relative to this eyeball, 5 is always the hypotenuse because that's the side that is opposite the right angle. But in this case, 4 is my opposite side, and 3 is my adjacent side. And then I look at this and say the sine of angle A. So here's my eyeball. These are my opposite hypotenuse and adjacent relative to that angle A. And then I look at SO. Sine is opposite over hypotenuse. So that'd be opposite over hypotenuse, which in this case would be opposite. We said that's 4, and the hypotenuse is 5. And that's it. The sine of angle A is 4 over 5. The cosine of angle A, relative to angle A, adjacent over hypotenuse, so that would be 3 over 5. And the tangent of angle A would be opposite over adjacent, so 4 over 3. What if I were to put in angle B here and ask for the sine of angle B and the cosine of angle B and the tangent of angle B? Well, now my eyeball has changed. I'm no longer in the red spot. Now I'm looking here, and this is going to be confusing because I've got multiple things in here. But here's my eyeball now because I'm looking at perspective angle B. And within angle B, I see that my hypotenuse doesn't change. That's the same. But notice that my adjacent and opposite have switched. This side is opposite angle B, so it's no longer adjacent. Now it's opposite. And this leg, not the hypotenuse, it's the other one that's adjacent. So when I do the sine of angle B, that's the opposite over the hypotenuse, so that'd be 3/5. The cosine of angle B, which is adjacent over hypotenuse, so that would be 4 over 5. and the tangent would be opposite over adjacent, so that'd be 3 over 4. That's the way we apply the ratios within trigonometry using sine, cosine, and tangent. Well, how does that help us? If I were given a problem such that I knew that this was a right angle, and let's say I knew this was 25 degrees, and I knew that the hypotenuse was 10, but I wanted to find out how long this side was, or how tall this side was. I'd begin by saying, where's my angle? What's my perspective? I'm coming from here. And let's call it angle A. The reason I choose that is because that's the angle I know, the non-right angle, one of the acute angles, that I have a value for. In this case, if that's my angle, this is the opposite, adjacent, or hypotenuse. It's way over here, it's on the opposite side. And this one, opposite the right angle, is the hypotenuse. So I know I'm dealing with O and H. And now what I want to do is consider whether it's a SOH, CAH, or TOA. That's this one. So I know that my function is going to be sine. And always, 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 after the sine function comes the angle. Sine of angle A is equal to opposite over hypotenuse. I like to write it out this way just to get your formula in place, and then substitute with values. In this case, sine of angle what? Well, in this case, my angle measure is 25. And my opposite side is x, and my hypotenuse is 10. Now I've got a proportion. It's a number equals a fraction or a ratio. And it messes with people to think about what sine is. It's actually not a value, it's an operation. So I can take the sine of 25, and that yields a value. What it will yield is a ratio. Something that will always be less than 1 because the hypotenuse has to be the largest side. So this must be smaller. So if I take a smaller number over a larger number, this will be less than 1. Now I need to solve for x though. So I ask myself, what's being done to x? Well, right now it's being divided by 10. So I like to think about this always as a proportion. And I multiply both sides by 10, or I can cross multiply. It does the same operation. This is my exact answer. X equals 10 times the sine of 25. If I were interested in coming up with a decimal approximation, I'd take my calculator, and you have to make sure that your calculator is in degree mode, not radian mode. I talk about that in another video. You can do that by looking at the mode function. In my case, you can see here that it's on degrees, not radians. And so I can say 10 times the sine of 25, and it gives me an approximate answer. 4.226182617. I've copied all the digits. That's still not the precise answer. That's a decimal rounded to this point. So any problem you do, it's going to ask you to round to the nearest hundredth, for example. This is tens, this is hundredths. So I'm breaking it there, which means I want to look at this last digit and see if the number after it is more than halfway or less than halfway. 6 is more than halfway, so I'm going to approximate this to the nearest hundredth as 4.23. Okay, that would tell me the length of this side. What if, on the other hand, I had asked to find this side? Would my problem change? Well, it would. I'd still use angle A as my perspective, but relative to A, this is my adjacent side. And so now I want to get adjacent into the game. I've already got hypotenuse. Which of my functions uses adjacent and hypotenuse? Well, that looks like the cosine function. So I could say that the cosine of the angle is equal to the adjacent over the hypotenuse. Then I substitute. Cosine of 25 is equal to the unknown y over 10. Cross multiply. Y is equal to 10 times the cosine of 25. That would mean that y is approximately equal to 9.063077787, but I want it round to the nearest 100, so I'd say 9.0. This is less than 1/2, so this number does not get promoted, so y is equal to 9.06. Okay, one more way that this happens, slightly more challenging version. Let's say that we're doing angle A over here, and I know that this is 32 degrees, and let's say that I'm looking for the hypotenuse and I know that this side length is 5. I begin the same way. Here's my eyeball. Relative to my eyeball, this is opposite, this is hypotenuse. Therefore, I know that I'm dealing with O and H. That's so. So the sine of angle A is equal to opposite over hypotenuse. So the sine of 32 is equal to 5 over x. Begins the same, but there's a little bit of a challenge in how it's solved. Again, if you do it the same way that I was suggesting, put it over 1 and cross multiply, what we'll get is x times the sine of 32 is equal to 5. We want to solve for x. What's being done to x now? Well, it's being multiplied by this thing, sine of 32, which is a number. It's in my calculator. I just can't see it yet. So to get rid of that, to make it x by itself, I'm going to divide by sine of 32. If I do it to one side, I've got to do it to both sides. These cancel, and I get that precisely x is equal to 5 over the sine of 32. That gives me a decimal approximation of 5 divided by sine 32, 9.4353999574. If I want to do it to the nearest hundredth, I'd say it's approximately equal to 9.4. That's more than halfway, so this is going to bump up to 9.44. All right, thank you very much.